Could the ductwork in your attic be making you sick? Stay tuned to find out how we can help you determine that and also give you some ideas on how to fix it. ProCalcs University. Hey folks, I'm Tom Platania with ProCalcs University, and today we're going to be following up on last week's conversation about positive negative pressure in the home, but we're going to be focusing on ductwork, on how the ductwork can cause those positive and negative pressures, but also how the ductwork can potentially cause major indoor air quality issues, which could cause allergies, health issues, all kinds of other stuff, mold, mildew. And we're going to dive into that today to kind of give you some ideas using some visual tools and also some good comments and whatnot to help you to grasp the concepts of these. But hey, let's start off with the hat challenge. All right, so the hat challenge, as you can see today, there's no wording on it, just symbols. Now, you have to figure out what hat it is. That might be easy for some of you. Looking at that symbol going, oh, I know what that is. In fact, I just got finished a meeting and I had this on, and the guy in the meeting, the first words out of his mouth, is that so-and-so? I'm like, yes, it is. I'm like, but can you figure out where we bought it? Now, it's not the usual places that you would think this hat would be purchased from. Okay, think outside the box. If you watched our past couple videos, you're going to hear about our travels and some of the places that we've been to. That will be a key clue for you to understand. So now something different that we're going to do is we're not going to reveal the answer until the end of next week's video. So it kind of gives you some time to look at it. Doesn't give the answer away right away. So have some fun with it. What does the hat represent, and where do you think we got it from? All right, so let's dive into the ductwork, and mainly ductwork that's in an attic. And we want to talk a little bit about first the build of the ductwork, where it's located, and kind of how it works. And then we're going to kind of dig into the potential problems that it causes. One, as it refers to negative and positive pressure, but also how it can cause issues with indoor air quality and things of that nature. So we're going to go ahead and switch over to one of our documents here. I can hear you see. Now it's kind of funny doing this. I actually did this entire video yesterday, and wasn't realizing that when I use my center screen, the one here that's right in front of me, and at the beginning of the video you saw all those screens. That's my actual computer setup with all 6 of those monitors. I got two 32 inches in the middle, and then I got 4 27-inch screens here. I do that for a lot of different reasons. One, for business. I also used to do some day trading, so it really helped me out with day trading. So I did the whole entire video, but I put everything on my center screen, and I'm clicking with the mouse, and I'm going through, and I'm showing everything. And then I go back and watch the video. You can't see the cursor anywhere. So I have to do it again. We'll have to set it up a little bit differently, but now you can see my cursor, right? And I can zoom in and zoom out. So, I don't know, one of those stupid mistakes you make, hopefully only once. As Johnny Dangerously said in the video, only once. So let's talk a little bit about ductwork. So typically what we're looking at is ductwork in an attic. Now, there is ductwork that's inside conditioned space. There's ductwork that's in the walls. If you're looking at a RHEIA system, a RHEIA duct system, RHEIA, which is a fairly new system that has a lot of its amazing benefits. Got some drawbacks that make it a little bit challenging. But it does have some good benefits. But typically the ductwork is going to be in the attic. And what we see is you can see here, we have a return. Now the returns, if it's designed properly, we prefer what they call direct returns. That means every room that can be physically closed off from the main area of the house, typically bedrooms, offices, not bathrooms, not laundry rooms, but main livable areas that would be closed off from the rest of the house. The best way, not the only way, the best way is to have a return that goes directly, just like you see here, directly into that room. And the reason being is we can then more purposefully extract air from that room, as well as purposefully put air in that room. And if you have the right balance of air, and I'm a firm believer, most people won't do this, or completely believe in not doing it. I'm a firm believer in putting dampers in returns and supplies, because otherwise it's just a big hole, and the amount of air that gets pushed out or sucked in is going to be determined based on a lot of external things like outside air pressure, duct sizing, air fan speed, and things of that nature, which may not always be consistent. But if I have a damper there, I can specifically determine exactly how much air I want going in the room. And with a damper in the return, I can determine exactly how much air I want to pull out of that room, which would typically be slightly less. So I'm always keeping a positive pressure in the room. That is a perfectly designed duct system. But I have very few, I can count it on one hand how many HVAC companies will accept the design or might accept it but will not install it that way. Okay, I'll get off on a tangent. We don't want to go in there. But anyway, so duct systems in the attic. Now, most of these attics that we're looking at that cause problems are from what's called vented attics, where the insulation is here, as you can see, in the ceiling, and it's not up here in what they call roof deck. And that's called an encapsulated attic, where the insulation's on the roof deck and not the ceiling. So with the insulation being in the ceiling, you can see up here, you can see what's called the thermal barrier. So this encloses here. This means that this is the part here that separates the house from the inside and the outside. So in the attic, where the insulation and whatnot is, this should be the thermal barrier, where there's basically a close off from the attic to the home. It doesn't always work because of hi-hats and leaky things, but that's what it's supposed to be. So that leaves everything in the attic, ductwork in the attic, to cause issues. So what we're looking at is we have a return that's pulling air in to the air handler, okay? And typically you would have a filter here, and so the air would go through, it would be filtered, it would then go into the return duct and then into the air handler. All right, so okay, no big deal, everything sounds good. But here's the issue. The first issue, and instead of going through the whole thing, as I'm going through each duct type, I'm gonna talk about the problems about it instead of going this way. You can kind of tie them together a little bit easier. So with the return, one, if we have the filter here, which would typically be in your ceiling or maybe in the wall or something, but typically in this case it'd be in the ceiling. If we have the filter here, okay, the air goes through, it's typically clean, and then goes into the ductwork. Big if the ductwork was perfectly sealed, then we would be confident that the filtered air would go through the ducts into the air handler nice and clean. And the how much better it's clean would be depending on the type of filter, whether it's from a MERV 5 all the way up to a 15, 16 or whatnot, which those determine how much. We'll do a video on filtration filters later on. So that's if, and I say if. But what if this filter's here and the air goes in, but the ductwork is extremely leaky? It has all kinds of issues with it. It looks like this. We got all these loose fittings, we got gaps, we got holes, we got all these problems in there. that are causing leaks. Well, that's not good. All right. So what happens is I pull that filtered air in, but now I'm sucking in air from all over this unfiltered attic. Also, an attic that goes to the outside, also an attic that potentially could have little critters and creatures crawling around and feces and all kinds of stuff that's being sucked into this. Remember, this is return, so it's pulling air in. So we have all these things that are pulling into this return with a filter here, so it's being pulled in on the other side of the filter. So it's not being filtered at all. Now it's going into the air handler unfiltered, and it gets into what's called the coil. Now the coil could be in the shape of an A, or it could be what they call a slant. Typically, air handlers in the attic like this would be most of them would be an A coil, but it all depends. And nowadays with the efficiencies and whatnot, most of them are A coils. But what happens is that coil is designed to remove heat, and when you remove the heat, you actually create condensation. Well, what happens when dust and mites and bacteria and stuff like that hit a wet surface? It sticks. And then what happens when it sticks? It's dark inside that air handler. So you have moisture, you have darkness, you have a food source. We get mold. Okay? All right, now the unfiltered air has gone through the air handler. It's left some of its contaminants in there, but now it gets into the supply duct. So what happens? Now we have all those contaminants that have been pushed into the supply duct. All right? Now, let's say, for argument's sake, the supply duct perfectly sealed. No issues. That nasty air is going to now come out and blow into each of the rooms. So now you're going to smell musty because of all the mites and particulates and mold or whatnot. You're going to smell musty air coming out of the vents. Not a good sign. But in this case, let's say that the supply duct wasn't perfectly sealed. Well, what's going to happen? Well, you're still going to get that musty air. However, yes, you will. The duct is pressurized because you're pushing air out, so the duct is pressurized. However, if you have openings and cracks and whatnot, like we showed you with that ductwork a second ago, in some instances, especially when you're going around like turns like this right here, you can actually create cavitation where the air is spinning and actually can create like we'll call maybe like a vortex or whatnot. I know there's fancier terms for it. I can't think of it right this second. But it'll create an issue where it'll actually create a suction. So it'll continue to pull in attic air even on the supply side. Okay? So if we're not properly filtering everything and we have leaks and openings and whatnot, we are just inviting all of these contaminants and this mold and bacteria and feces and all this nasty stuff and reintroducing it into our home. So some of the ways that I would recommend, besides the sealing of the ducts, and we'll talk about the sealing of the ducts in a little bit, but let's in a perfect world, let's say everything's going great. Maybe the return's got some leaks. But the way I like to do this, and we specifically design, and when I say we specifically design, I mean design our air conditioning systems, because air handlers only have the capacity to be able to pull and push so much air. Just like you and I, there's a point in time where if I need to push something, there's a point in time where the item becomes too heavy and I can no longer push it. It's reached my max. Same thing with pulling. There comes a point where the weight gets too much and I am no longer able to pull it. That same thing with air handlers. If I have something that's allowing me to pull air, so we have a filter, and I have air that I'm pulling through that filter. But if the filter gets too clogged or it's too thick, I can then start to restrict how much air I can pull through that, up to and including not to be able to pull anything, and you could cause motor failures, you could cause all kinds of other issues. So when we design our air conditioning systems, we actually design them making the ductwork a little bit bigger to take those things into consideration, that we want you to have a really good filter to filter out all these particles and particulates and whatnot. Also, the way I recommend, this is my recommendation, if you have returns in your rooms, bedrooms, main living room, things of that nature, my personal opinion, everybody's got one, you know what they say about opinions, right? But this is my opinion. This is 30 some years of experience and education and design and all this other stuff. Is I like to put what they call a baseball filter in this return here. And a baseball filter, it's kind of a joke that, yeah, that's all it catches is baseball, but it's just an inexpensive MERV 234, something like that filter that catches the bigger stuff before it gets into the return ductwork. Okay, so you can see that here. So if I filter it with a just basic filter, I'm capturing a lot of the particulates before they get up into the duct system. Which one, let's say there's no leaks in the return, having a good filter here is going to make sure that I don't dirty this duct up so much that I have to constantly have it cleaned. Because if I have no filter here, that means all the dust, debris, and particles and whatnot that are in my home, no matter how well you clean, they're there. It's going to get up in this duct. And even if I have a filter here in the air handler, still unfiltered air is going to get into that duct and it's going to cause things to grow. Okay, so the baseball filter is going to capture the bigger stuff. All right, so the smaller stuff is not going to stick as quickly, and it's going to flow in the airstream a little bit better. But here is where, right here at the air handler, the last point of contact, where we put our best filter. Now, it's in an attic, but if you get a really good filter, most of the time they don't have to be changed for sometimes 3 to 6 months, if not more. And with that, having a maintenance agreement with your HVAC company, they will be the ones that, if you don't want to do it, which I know a lot of people don't, will go up in the attic, replace the filter for you, make sure everything's running well, and clean it out. This is going to ensure the optimum filtration to help keep your ductwork clean, but also help keep your air handler clean. Also, if you have any leaks in this return, which is what we're going to talk about in just a minute here, if you have openings in this return and you are pulling in unfiltered attic air on the other side of this filter here, you are now going to be able to capture that dirt, debris, dust mites, bacteria, feces, all that garbage in this filter here. So you have double protection. Okay. So that's how I would set that up to help keep everything clean. But let's focus on the next point. The next point I want to focus on, let's kind of zoom in here a little bit. The next point I want to focus on is when we talk about negative and positive pressure in the homes. And let me explain how the ductwork can be a big part of that. So let's say that we have this return here and it's pulling X amount of air into your home. And you know, that air is actually classified as CFMs, cubic feet per minute. That's how we calculate the air. So let's say that, let's use a number that says 1,000. 1,000 CFMs of air are going into it. Don't focus on the CFM, just focus on the number. So we're pulling that into here. All right, so 1,000, we pull it into this return. Now, one issue, one area be, okay, let's say the return is perfect. Okay, so I'm pulling 1,000 CFMs out of the house. I'm not able to pull any other air from this duct except from the house. So 1,000 CFM goes in, there's no leaks in the ductwork, 1,000 CFMs go into the air handler. Now we get to the supply. Okay, so when we get to the supply, we're now going to push that air out. So we should still be around 1,000, and we'll talk about leaks in the air handler in a minute. So we should still be at 1,000. So I push 1,000 out. Now I get to my supply duct, but remember that duct we showed you a couple seconds ago? This one? Look at that. All this nasty open ductwork that's got leaks and cracks. What's it doing? Okay? It's it's causing air in the supply duct to escape into the attic. Now, again, we talked about you could create some minor vacuums, but those are very minor. Your biggest loss is going to be your positive pressure air escaping through cracks and crevices and so on and so forth. So now 1,000 comes in, it goes into the supply duct. But once we get into the supply duct, we have so many openings and leaks. Let's say we end up losing 200, it's a big number, but 200 CFMs of air in the supply before it comes out of the ducts. Now, this is a single duct. This is a single duct. In most homes, you're going to have a supply vent in every single room. So if you were to add all those together, then you would come up with the reduction. But the more ducts you have, also the opportunity for CFM loss. So if every duct had a percentage of loss, you could actually be a lot greater than the 200. So now we have 1,000 going in. By the time we get out here, we've lost 200 because it's blown into the attic, and now we only have 800 coming out. Well, let's look at the math there. If I'm pulling 1,000 out of something, but I'm only putting 800 back in, that's an offset. That creates more suction than it does pressure. So what's that do? It puts the house under a negative pressure. Okay, so that's one of our big issues, is putting this house under a negative pressure because we have leaks in our ductwork. Now, let's look at it this a different way. Let's say I have my 1,000 CFMs at this, because this air handler wants to pull 1,000 CFMs. It says, okay, all right, let's go. You're turning me on. I want 1,000 CFMs of air to come in as ductwork. I'm going to start pulling away. Here I go. So I start pulling away, and it wants to pull 1,000 from the house, but here's the problem. I got leaks in my return duct. So what happens? Air is going to take the path of least resistance. If it can pull air out of these cracks and crevices easier than it can pull air through this grill or this filter, it's going to. So instead of pulling the full 1,000 out of the house, I only end up pulling 800 out of the house, but I'm pulling the other 200 from the attic. Now, a couple different problems with that. One, if I'm pulling 75-degree air from the house and I condition it, most air handlers can do about 18 to 20 degree temperature difference from air going in to air coming out. That's a good, properly running system. But that's only if I'm taking 75-degree air in, 18 to 20 degrees difference. Let's use 20 degrees for easy math. Now, the air coming out could potentially be 55 degrees. So if I'm dumping 55 degrees air into the house, I have a better opportunity of getting the house to a 75-degree thermostat setting. But if I'm bringing in 75-degree air here, but I'm introducing 120, 130-degree attic air, well, there's mathematical formulas that'll determine, based on the quantity of air and the velocity of the air, how much this 120, 30-degree air in the attic will affect the temperature difference of the 75-degree air. And, well, if it changes it by 5 degrees, now you have 60-degree air coming out, which common sense kind of tells you the hotter the air, the longer it's going to take to get the house down to the comfortable temperature I want. So you end up with a problem. All right, well, let's say that the supply duct is perfectly sealed. So what's happened? Okay, now I'm supposed to be pulling 1,000 from here, but I only pull 800 from the house. I pull 200 from the attic. So I still got 1,000 CFMs, and I'm still blowing this out 1,000 CFMs. I'm just getting it from a different place. I'm getting 800 from here and 200 from the attic. So I still got 1,000, and now I push 1,000 CFMs back into the house. Now I'm pulling 800 CFMs, and I'm dumping 1,000. Now we're on the opposite. I'm over pressurizing the house and under pressurizing it. So we now have a different issue. Now, we want the house to be under a slight positive pressure. That's a good thing. A slight positive pressure. Have you ever gone to a restaurant or a commercial building? And the reason I use these is because they're bigger systems. They have more opportunity to have these, especially restaurants, because restaurants have these big giant uh, the grills and the stove, and they have these big giant exhaust fans, and it's very complex. We do this all the time because we work on a lot of buildings like Papa John's and all kinds of other places. We work on a lot of restaurants um, and commercial buildings. You have to have the right right setup. But if have you ever walked into a building and you go to pull the door and it's really hard to open, or you go in and the door's like kind of flopping slightly open all the time, or you open it and there's just like this massive tornado gust, hurricane gust of wind blowing you down. Well, that's what happens when a building is overpressurized or underpressurized. There should be a slight difference. It could be 5% or less difference of supply versus return. So we slightly pressurize the building to help push any air through any cracks, crevices, and things of that nature, and also not allow the outside elements to be sucked in to put the house under negative pressure, because that's what happens with, we talked about last week, where all this stuff from the outside comes in and the moisture ends up embedding itself in all of our porous materials, our couches, our rugs, our different things of that nature, and we run into problems. So ductwork can be a huge issue with this. Making sure it's properly sealed, making sure that it's adjusted correctly, okay? And you would think, well, just get my HVAC guy out here to do this. I'm going to tell you right now, less than 5% of HVAC companies are going to know what I'm talking about. Not saying that they're not good companies, but a lot of them have got so stuck in the past of what they were taught, they don't educate themselves in more detail. Even today, we constantly send stuff to HVAC companies, and it's like a deer in a headlights. And it's like, I'm sorry, how did you get your license? Well, after 7 times, I passed it. Okay, well, this is a concept that you need to be aware of, but most HVAC companies are not aware of it, and with a lot of us, sometimes if we're not aware of something, we think it doesn't exist. Well, as part of our kind of tagline here, you don't know what you don't know. So always leave your eyes open, your ears open, so that you can gather this information. So we want to keep the building, your house, under a slight positive pressure. Having exhaust fans that are too big or left on constantly can cause an issue with negative pressure in the home. So we want to be careful with that. It's okay to have temporary negative pressure. Turn an exhaust fan on. You're going to cook. I cook in my kitchen a lot. I constantly have that fan on when I'm cooking. Yeah, at that point in time, I'm going to create a slight negative pressure, but for a reason. And if it's designed properly, like in kitchens and big kitchens of restaurants and whatnot, the exhaust there, and you could be pulling 2, 3, 4,000 CFMs of air out because you're pulling all that heat from the grills and the smoke and all that. So you're bringing in fresh air at the same time, but what we're doing it right at the grill. So we're almost exchanging right there where all the smoke is. We're just exchanging the air, but we leave it at a slight negative. So if we're sucking out 4,000, we may only bring in 3,000 to 3,500. So we still create a little bit of negative pressure in the kitchen area, but overall in the building, we're going to try and keep it under a slight positive pressure. And we make sure we do that during the design phase. So having these issues and the leaks and the holes and all these different things and not filtering it properly, they're all going to cause indoor air issues, negative pressure in the home, health issues, allergies, mold. Mold, it's going to creep up. And I mean, it's going to be behind your walls too, because the house is being put under a negative pressure. So there's space inside your walls, especially if it's a frame wall or even if it's a block wall with a fairing strip or something on it. you're going to have air in there. And if air seeps in there and it gets trapped and you get moisture in there, you are going to end up having mold growth between your walls. So make sure that we determine. Now, how can we determine if the house is under a positive pressure? Well, some things you can do is actually have a home blower door test done, which we'll talk about blower door tests for the whole house at another time. There's going to be a quick picture up here that we'll have Marie put up that's going to show what a blower door. I think we put it in the last video, but just real quick, we'll put the blower door up there for the whole house. The key to finding out, since we're talking about ductwork, is there is a device called a duct blaster. Okay, and what it is you have a, let me make sure I put the cursor in the right area this time. You have this blower here that's pushing air through the return, and he's got this taped off to the return. Now, you also go in and you're going to tape off all the supply ducts, grills as well. Not the ducts, just the grill. So you want the air to push in through the return, up through the return duct, and then it's going to go all the way through into where you have the supply grill. So let's go back to our picture up here. So what he's doing is he's got this return blocked off and he's blowing air into here, and then it's going through, but then he's got this taped up over here. So what he's trying to do is he's trying to create a closed system that allows it to pressurize. And then using this device, he can determine how much air is escaping. So basically how big the leak is. And then he can make a determination. And that'll tell you. That's a surefire way. There's no guesswork, not having your AC company come up and look around with flashlights and stuff, or turn the air conditioner on and put his hand out there to try to feel for stuff. He's not going to find it all. But a tip, when I'm certified for ResNet Energy Rater, where I've actually gone out and I've done duct blaster tests on many homes. I've done a whole house blower door test all the time. I'm certified for it. But what we would do is take it one step further and get a smoke device to actually allow this right here to pull smoke, harmless smoke, and pump it into the system. And the cool thing about that is when you go and you're in the attic and you're walking around, you will start to see smoke coming out of all the little cracks and crevices. So you know exactly where the leak is. No guesswork, not feeling around with your hands. Oh, I think that's a leak, or maybe it's a draft. You're going to see smoke coming out of it. So you're going to know 100%. And then somebody goes up there and they put tape and they mask it and they seal it and they do all those things to make sure you have as well of a sealed duct system as possible. Now, we briefly talked about the air handler. The air handler here can actually have leaks in it as well because it has panels, it's got screws and different things like that. And when they carry them up in the attic, the cabinets can get twisted and whatnot and cause the gaps to be even bigger. All air conditioning manufacturers are required that their air handlers have a 2% or less leak factor when tested. And all the equipment is tested on the designs. So, but once it gets to the HVAC contractor and it gets unboxed and it goes into the house, I mean, sometimes they take them apart in pieces, get them up in the attic, take panels off, take coils out. They do all kinds of things. And when they put all these back together, if they don't put them back together perfectly, you're going to have even bigger leaks than that. So one of the ways that we would recommend is that once it's put back, is they go in and they put metal tape or insulation tape, because metal tape is okay for sealing the leak. But the problem is if I pressurize the air handler and I'm blowing cold air and the cold air hits that thin layer of metal tape, you're going to have condensation because I got 130 degree air in the attic. I got 55 degree air on the other side of it, and I'm going to create condensation. So a good thing to do there is have them use like an insulation style tape, okay, and tape all the cracks and crevices and where the refrigeration lines come out, have them seal all that up really good. Now, one manufacturer, and there might be other manufacturers that have already done it or are looking to do it, but one manufacturer who really took this to the next level was Train. Train has an air handler model line that actually works opposite. The air handler cabinet is under a positive pressure because instead of, so let's go back to this picture. So instead of the blower being at the bottom, pushing, I'm sorry, the blower would be at the top and it would be pulling air across the coil, okay? Pulling air across the coil and blowing it out. What Train does is they put the blower at the bottom, which pushes air through the air handler, keeping the air handler under a positive pressure to help avoid pulling in attic air. You could still, if you have gaps, you could still have air escaping, which is what you don't want, but at least it could also help with pulling in unwanted, unfiltered air into the air handler. And also they're nice, the composite cabinets. I like them. I think they're great. They're built like your refrigerator where you have a clean surface, and the insulation's on the inside of those two areas like your refrigerator. And a lot of air handlers, you have the cabinet and then you just have insulation, porous insulation on the inside of the air handler, which is open to the air. Hopefully they're going to have some concepts to go away with a lot of that because that adds, the minute that gets moist, the minute bacteria and whatnot gets on that, it's done. But with the Train cabinets, with their composite air handlers, you actually, somebody can go in there with a nice sanitized cloth and wipe down, just like you would do the inside of a refrigerator, wipe it all down and clean. I love those air handlers. I'm not pitching Train or whatnot, but I just love that air handler concept, and I think it's a really, really, really great thing. So I hope that this information, I want to make this video too long. I went a little bit longer than I should. But I wanted to gather this information to talk about ductwork and talk about some of the health issues and whatnot that can come up with it. So don't forget about the hat. Hey, if you liked what we talked about today, I know I should have asked you this a little bit sooner, but go ahead and click the subscribe button. Maybe by now, Maria's put the little subscribe bell and thumbs up in there a couple times for you to remind. But if you really like this, or if you want more content to come to talk about things that interest you, go ahead and smash that like button. Go ahead and subscribe. Turn that bell on so every week on Friday, depending on how busy you are, the video will get there on Friday. Just not always a certain specific hour that it'll be there, but the videos are going to come up and they will be posted every Friday for you to review, for you to look at, to put your comments in, and then we're going to look at your comments and we're going to be able to do videos in the future for that to really help you out. So don't forget to in the comments to put your results on what you think the hat is and where you think we got it from. And remember, you can teach the right person anything. You can't teach the wrong person anything. Are you the right person?